time for a journal entry for general compounding formula. So remember to put your name, and then a description of the general compounding formula is going to be a formula that's used to calculate compounded interest and with this formula you deposit a big chunk at the start. I spelled chunk wrong. A big chunk at the start. You earn interest on interest NT times and get a bigger chunk at the end. Okay, so we are getting interest on interest with compound interest, and the other idea that you've got to keep in mind is we put in a big chunk of money, earn interest on interest for some number of times, and then we get an even larger chunk out at the end. So the formula is F equals P times the quantity 1 plus R over N raised to the NT power. This should look very familiar to you. The F is the future value, which you end up with. The P is the present value, or the starting value, and R is the rate. Remember, you want it in decimal form. T is time in years generally, and N is the number of compoundings per year. And I'm going to put over here the types of compounding just because that's generally something we forget about. 1 for N would be annual, because annual happens one time a year. And if we have 2, that would be what you call semi-annual. You might see some of these on your homework. N equals 4, that would be quarterly. Because quarterly, there are 4 quarters in a year, and N equals 12 would be monthly. You may see an N equals 52, that would be weekly. And finally, N equals 365, that would be daily. Okay, so some keywords that are going to tell you that you need to use this formula would be compounded, and then you would see like annual, semi-annual, one of those. So we might say monthly, compounded monthly. That's going to be the biggest clue for you. And then the other things you have to look for in the keywords, you also have to look to see a big chunk and no payments. Because later we'll look at some types of formulas that have payments every month, and you can't use the general compounding formula in the way that we're showing it here. So steps, you're going to fill in as you see fit for yourself what steps you follow to use this formula. Things that you forget and want to remember, that's a good place to write that. And we have 2 problems. I'll see if I can pick the harder one. You deposit $3,250 in a savings account, and you see how you're putting a big chunk of money in your account, and it's getting 9% interest, and here's the keywords compounded monthly that are telling you that you need to use the general compounding formula. And assuming no withdrawals are made, how much will you have after 4 years? That one sounds pretty straightforward. Let's look at the next one. Your cousin deposited some money into an account earning 4.75% interest compounded daily. So that compounded daily tells me general compounding formula, and he deposited a chunk of money. He's not depositing every month, so that tells me compound interest formula as well. He now has $4,060.17. How much did he originally invest? And that one looks a little bit harder to me, so I'll go ahead and model that one for you. And we can look at the F is the future value. What he has at the end is 4060.17. So we know the future value, and so I'm assuming the present value is what we don't know. And I can confirm it here. How much did he originally invest? So that means we don't know what he started with. We've got the P right then. And so the R is going to be 4.75% interest, and I have to convert that to 0.0475. Remember, you just divide by 100. And then N, the number of compoundings, we have daily. So that means 365, and then the time, how many years, is going to be, I see it there, 3 years, so the T is going to be 3. So first thing I want to do is write down the formula. So it's F equals P times the quantity 1 plus R over N raised to the NT power. And then I want to show it one more time with all the values I know. So I have 4060.17 in for the F. The P is staying as a P, and then I have 1 plus. My R is 0.0475, and my N is 365, and my exponent is 365, and I'm going to write it down below, but it's times 3. So when I'm looking at this formula, the first thing I want to do is figure out that exponent, because I need it as a number, so when I come back to it, it's ready. I'll show you on this calculator. So I can do clear, and then 365 times 3, and there I get 1095. So I'm just going to write that. I can find my pen. There we go. Okay, so instead of that I can put 1095, and then starting inside my parentheses, the division comes first, so 0.0475 divided by 365, and then push enter. I have that big long digit there. I have to add 1 to it next, so plus 1. And I'm going to write just a little bit down on this page just so we can see what we have. So I have 4060.17 equals P times the quantity 1.000130, and it goes on, raised to the 1095 power. So I'm going to go ahead and do that. To the, remember, is the caret on this calculator. If I'm using this calculator, it's this Y to the X button. So for this one, caret, and then 1095, and there's my enter. So push enter, and so now I have 4060.17 equals P times the quantity 1.1531, and it goes on. And now I want to divide both sides by that 1.15, and remember that's the same as multiplying by the inverse. So I'm going to go ahead and use the inverse button, which is this x to the negative 1 for this calculator. If I was using this calculator, it is the 1 over x button, so you can get a sight for both of those. So I'll do the inverse of this, and then I can just type it in on this calculator and say times that 4060.17 and push enter. So for this problem, I end up with P, I'll put it on the left, equals 3520.96, and it looks like a 1 is following, the ink blot's in the wrong spot. So 3520.96. So it's money, so we can think of it as $3,520.96. So that's how much this cousin deposited initially. And we could take the $3,520.96 and plug it into the formula as your principal, your starting value, and see what we get for F to double check yourself. That's just fine to do it that way if you want to. So go ahead and finish this journal, and that means work out problem number 1 and fill in any steps or notes that you need to keep you on track using this formula, and then email or fax this page to me and I will get you a grade and get you back any comments on your work.